Assalamualaikum warahmatullahi wabarakatuh and a very good day to all. I'm Dr. Nazrina binti Abu Bakar. Assalamualaikum warahmatullahi wabarakatuh and a very good day. First and foremost, I would like to say very very sorry to all of you because I'm not able to have a class face to face with all of you because I am actually very very sick. I have cough as well as a very bad sore throat. And as well, I tried to make the class online, synchronized online, but somehow I'm afraid that the internet connections is bad. Therefore, I decided to make a recorded video for all of you to refer to my lecture today. And I really hope that I'm really hope that when sharing this lecture as a video, therefore, if let's say you are unable to understand part of it, maybe you can go back and recap and rewatch it again and again so that you can understand, alright? So as far as for today, we're going to take a look at the gas transport between lungs and also tissue. So when we talk about the gas transport, so what are the gas? So we're basically talking about the oxygens as well as the carbon dioxide. Right, I'm so sorry I have to swallow my saliva frequently because it's very very painful. Okay, so when we talk about the gas transport, we are actually talking about the oxygens as well as the carbon dioxide and how does this oxygen and carbon dioxide being transported in our body system. And kita tahu kan oxygen is very very important. Bila you COVID pun zaman yang first that we get introduced, we got bombed by the COVID. So we do know that the oxygen is really crucial. Then only we realize that the amount of the oxygen is really really important inside our body. And if let's say you don't have enough oxygen, so your body system might get failure. Alright. So before we go further, let's move on to the learning outcome of this topic. So inside the gas transport, what should we learn is the first and foremost before you get to go inside your body, you need to know the compositions of the air in your environment first. So what are the air that are available in our surrounding? That's why we live on Earth, right? So basically, it's not only the compositions of the air, but you need as well to get to know the compositions of the air at the sea level as well as the high altitude. For example, like people that live in the sea level, macam kita sekarang ni duduk di pantai pun, so senang kita nak cakap at sea level. So the compositions of the oxygen is different in comparing when you are at high altitude. Maksudnya kalau awak 36,000 above the feet, above the sea level, for example like you're riding an airplane, for example like pergi Tawau, so the compositions of the oxygens is right now is different. That's why kalau orang yang pergi travel jauh lagi, pergi Europe ke, the pilot is basically inside the airplane itself, there is a pressurized oxygen inside there, so they akan releasekan oxygen so that you can breathe normally. Alright, so then we get to know the compositions of the air done in the atmosphere. You also need to know the compositions of the air inside your body. Okay, we get to know it later, right? And then we're going to take a look at the transport of the oxygens as well as the carbon dioxide inside our body. How does it being transported? Okay. And then let's move on to the next one. It's actually the concept of diffusion. So when you get to know the concept of diffusion, so when you start being introduced with the science lesson, masa awak sekolah dulu, masa awak kecil dulu, okay, so you do know that the diffusions will occur when there are two pressure gradient. Maksudnya there is one pressure gradient that is high and another pressure gradient that is low. So from the high pressure gradients to the low pressure gradients, so then only diffusions will occur, right? So not only that, we also need to know about the pressure gradient as well, right? So the pressure gradient, when we talk about the, tadi kita cakap gradient saja. Now when we talk about the pressure gradient, the difference in the pressure. Okay, so macam tadi saya cakap, at the sea level, the pressure gradient of oxygen is different, but then when you are at high altitude or you hiking a mountain, for example, Everest mountain, so the partial pressure of the oxygen is different, and this partial pressure may influence the diffusion of the oxygens inside your body as well as carbon dioxide. We're not talking about the oxygens, it's applied to all gaseous, but right now we are talking about the oxygens and as well the carbon dioxide. We're talking about our system, respiratory system. Okay, and then we're going to know about the role of hemoglobin. So when I say the transport of the oxygen and carbon dioxide in your body system, you automatically will think about the red blood cells. So what are in the red blood cells? What is in the red blood cells that play a role in carry all the oxygens and whatnot is actually the hemoglobin. Okay, so other than hemoglobin, in what form does this oxygen and carbon dioxide being carried in our circulatory system, blood system? Okay, so and then other than that, we're going to get to know the Bohr effect as well as the Haldane effect. Right? So ready? So now let's move on to the first sheet. Okay, before you get to know your body system, you need before you get to know the transport of the oxygens, transport of the gases in your body, you need to know about the organ system in your body that play a role in transporting the oxygens. Alright, so first and foremost is the lung and its surface area. Okay, so as far as the anatomical concern, you get to know that in our alveoli, you are actually having 300 million of alveoli. Ni yang buah anggur ni, grape like structures here. If you get to know it, you are actually having 300 millions of the alveoli. But then if you spread this alveoli, you cut in the sections and you spread it through, you might see they are actually 4.2 milliliter or they are actually 70 meters square. So when you spread it over, you cantum, you merge, you spread it over, it's actually like a tennis court. It is really big. And why they increase in the surface area like this? It is because to increase the effectiveness or the efficiency in diffusion of the oxygen, so that your body system, your circulatory system can get active, can get enough amount of the oxygens to be carried out to the whole tissue. Okay. Alright, so now let's move on to the several factors that may affect the rates of gaseous diffusion. This is applied to the general law. Okay, kita tak cakap lagi pasal body system. We are talking about the general law. So there are several factors that affect the rate of the gas diffusions, which involve the thickness of the respiratory membrane. Okay, the thickness of a certain thing. If let's say there is tint, means that the when we say that it is a thin membrane, so it means that it will increase the rate of the diffusion. So when it is thick membrane, so it will decrease the rate of diffusion. That's why if you take a look at the lung and the blood vessel as well, so they are actually a very thin membrane right over there. It's because it's going to make the diffusion effective. Okay, so now let's move on to the surface area. I did mention to you just now, when you spread through, so large surface area increase the rate of diffusion. And then this also depend on the solubility. So if let's say that certain gas, it is highly soluble, so it can diffuse effectively. If let's say it is not soluble, so it cannot diffuse effectively. Alright, now let's start. Now number 4 is the molecular weight. So if let's say you have a certain gases that is increased or high in the molecular weight, so it will be difficult for it to diffuse. And last but not least is the pressure gradient, which I emphasized at the learning outcome just now. So these pressure gradients is really crucial in your body systems. It's not only this, but all of these points, all of these factors play important role in facilitating the diffusions of the gas inside your body system. Alright. So now let's move on to the oxygen transport. So first we go to the oxygen transport first, and later we're going to look at the carbon dioxide transport in our systems. We go to one by one gas, right? So now let's move on to the oxygen's delivery system. So first and foremost, you need to know that your delivery system, gas delivery system in our body, is basically composed of the lung and also the cardiovascular system. If let's say you have a lung but you don't have a heart, so how does this oxygen going to be circulated going to be delivered to the rest of the system? It cannot. So it must need the help of the cardiovascular system. So this cardiovascular system, this lung system, respiratory system are actually working together to make the oxygen delivery good enough. Okay, so now let's move on to the amounts of oxygen that being delivered in our body. Okay, so how much oxygen is being delivered in our body is depending, for point number 1, is the amount of the oxygens entered into the lungs. Okay, so if let's say you are caving, you go for caving, maksudnya masuk gua, very confined space, bukan gua yang besar, bukan Google Dam bukan Google Dam, but for example like a very small cave, you get into it, so you cannot breathe, so means that the amount of the oxygen inside there is very low, so there is low amount of the oxygen that entering your lung. Okay, so the oxygen delivery is depending on the oxygen amount that enter into your lung. Not only that, what about your pulmonary system as well? Point number 2, if let's say you have a lung but your pulmonary systems cannot, but your pulmonary system cannot, what do we call, cannot function well, cannot undergo gaseous exchange, so it's useless. So let's move on to the point number 3. So point number 3 is the blood flow to the tissue. So if let's say you have a cardiovascular system problem, you have a very good lung but somehow you have a heart problem, so your heart cannot deliver the oxygenated blood to your body, so this one we call it as the blood flow system. So it affect the blood flow to the tissue, so jam. Alright, so point number 4, so blood oxygen carrying capacity. You have a very good lung, you have a very good cardiovascular system, but somehow your blood itself, your delivery system itself, your cable itself are unfunctional, cannot bind oxygens and bring these oxygens to the tissue, so it is useless as well, right? So all of this point is very important to be part of the oxygen delivery system. Okay, pernah dengar tak orang yang ada anemia? Okay, anemia dia tak ada masalah dengan lung, dia tak ada masalah dengan cardiovascular system, but they have a problem with the red blood cell system. Okay, the oxygen, the transportation system. So it might affect the oxygen delivery as well. Okay, so now let's move on to the amount of oxygen in the blood. Okay, so the amount of the oxygen in your blood. So how much oxygen that your blood contain to be carried to your tissue. So it's actually depending on the amount of the oxygen that being dissolved. Right. Just now I did mention that we have carbon dioxide, we have oxygens, we have carbon dioxide molecular weight, oxygen molecular weight, carbon dioxide solubility as well as the oxygen solubility. So how much this solubility influence is depending on this certain gas. So any amount of the oxygen that being delivered going to determine the oxygen content in your blood. Okay, as well as the hemoglobin concentrations in your blood. Okay, so let's say that you have a good lungs, the lungs can exchange and the oxygens can diffuse into your delivery system, which is your what we call your circulatory system, the saluran darah you. But then the hemoglobin concentrations is very low and very poor. It might affect the content of the oxygens in your blood. Okay, similarly to the Hb affinity towards oxygen. You have enough amount of hemoglobin. Just now, you don't have enough amount of hemoglobin. For point number 3, you have enough amount of hemoglobin, but somehow that is not a functional hemoglobin, so it cannot bind to the oxygen. So it may affect the oxygen concentrations in your blood system. Okay, so for example, point number 3, Hb affinity to oxygens. So I give you one example. It's like those that having a sickle cell anemia. So their red blood cells, the hemoglobin is unfunctional, so they most likely to get pale and etc. because they are unable to deliver the oxygens very well. Alright. Okay, so now let's move on to the concept of kita belajar dulu basic idea dulu, then we go through how does this oxygen being carry on in our body system. Okay. Sorry, sangat sakit. Alright. So let's move on to the external respiration. Okay, so we have internal respiration, internal respiration as well as external respiration. So what does this different? Okay, what are their difference? So their difference is that external respiration is basically, it's not talking about how your nose and the air is keep changing. No, it's not. Actually, external respiration is talking about the gas that is diffused, the oxygen that is diffused from the air in your alveoli. Okay, external respiration is in between alveoli in your lungs as well as the pulmonary capillaries. Pulmonary capillaries ni dekat mana? Dekat lung you lah. Capillary dekat lung. Okay, it's actually called as the pulmonary capillary. So external respirations occur in between the gases of the oxygens that occur between the lung and also the pulmonary capillaries. Similarly to the carbon dioxide lah, diffusion of the carbon dioxide from the pulmonary capillary back to the alveoli in the opposite manner kan. Oksigen masuk ke pulmonary capillary, carbon dioxide masuk pula ke dalam lung. So they are talking about the external respiration. So when I ask you questions, what does that mean by the external respiration? So please don't answer me, oh, external respiration ni maksudnya hidung kita bernafas, angin tu keluar dekat atmosphere. No, it's not. Okay, so it's actually from the lungs to the pulmonary capillary, the gaseous exchange in that region. So what does that mean by the internal respiration? So internal respiration is that the diffusions of the gas that coming from the blood. Okay, ni dah pergi dekat dalam sel kat bawah ni. Ni saya dah salah ni. Ini gambar ni is not applied. Okay, dia kena pergi this one. The internal respiration. Ni external respiration. So this is external respiration. So external respiration is the one that occur from the capillary, blood capillary. Ni pulmonary capillary maksudnya yang duduk dekat pulmonary lah. Capillary di pulmonary, kita panggil pulmonary capillary. So blood capillary means that the one that exists in your peripheral body region is called as the blood capillary. So the diffusions of the blood capillary to the body cells, the gaseous exchange that occur in this region, we call it as the internal respiration. Okay, please get the difference between the external respiration as well as the internal respiration. So now only we can get to know about the gas exchange. So how does the gas exchange in between alveoli to the pulmonary capillary in the external respiration, as well as from the blood capillary to the tissue? So how does the gas exchange occur? It's actually depending on the partial pressure gradient. That's why I did mention just now, you need to get to know that the partial pressure gradient is actually a very fundamental idea, a very fundamental concept on how does this gaseous exchange will occur. Alright, so just take a look at this example. Okay, I hope you can see my laser pointer over here. So if you take a look at this diagram, you might see that at the dry air, the partial pressure of the total atmospheric pressure is actually 760 millimeter of mercury. So in that partial pressure of the atmosphere, how much pressure of the oxygen is available? So partial pressure of the oxygen in the atmosphere is actually 160 millimeter mercury, and partial pressure of carbon dioxide in atmosphere is actually 0.25 mm of mercury. Maksudnya ni kat mana? Ni kat luar lah, dekat surrounding, dekat atmosphere, dekat persekitaran you. Okay? But then, when this air, alright, the air that you breathe in get into your lungs, its partial pressure going to be different and going to be changed. Alright, let's take a look at the partial pressure of the oxygen first. Alright, just now in the atmosphere it is 160, but once it get into your alveoli, you may see that its partial pressure now become 100. Dah reduce 60 dah. Mana pergi 60 tu? Nanti kita akan tengok. Okay. Similarly, to the partial pressure of the carbon dioxide, okay, if you take a look at the partial pressure of the carbon dioxide in the alveoli, it is 40 mm of mercury. Banyak kan? Partial pressure of the carbon dioxide dekat alveoli. But then dekat atmosphere berapa? 0.25. Jadi dia akan diffuse daripada mana kepada mana? From high pressure gradient to the low pressure gradient. So means that carbon dioxide will diffuse from the alveoli get to the atmosphere. But what about the oxygen? Oxygen partial pressure in the atmosphere is high, and partial pressure dia dekat alveoli is low. Therefore, from high is going to move to the low region. From the atmosphere, oxygen will move to the alveoli. That is the concept of breathing occur. Okay. So later we're going to take a look at the arterial blood pressure, venous, and so forth. Slowly, okay? Alright, so now before we go further on the partial pressure, we need to know the partial pressure of gases first. Okay? The concept of the partial pressure first. Tadi just a prelude saja. Okay, gaseous exchange depending on the partial pressure. So what is partial pressure to actually? So this is actually coming from the Mr. Dalton, John Dalton. John Dalton, the handsome guy right over here. He's actually come up with the partial pressure of the gas. I do not know how does he find the idea, the gas that available in your surrounding. Nak tahu dia kira macam mana kan. Tiba-tiba dia terfikir nak cakap, oh kita ada gas lah, kita ada campuran gas dekat sekeliling dekat atmosfer kita. Tak tahu macam mana dia terdetik dia tu, dia nak cakap macam tu. Okay. So what Dalton come out is that the total pressure is actually becoming from the pressure of gas A plus with the pressure of gas B plus with the pressure of gas C, jadilah total pressure. So the pressure of the atmosphere total is 760 mm of mercury. We call it as the barometric pressure, PB, barometric pressure. So the total of the gas, the pressure of the gas is 760 mm mercury. For example, let's say we imagine that the partial pressure of A ni adalah oksigen. Oksigen tadi saya cakap berapa? Atmosphere 160. So kita katalah 160. B ni apa? Carbon dioxide. You tambahlah carbon dioxide 0.25. Apa lagi gas yang ada kat atmosphere ni? You tambahlah you akan dapat the total of the partial pressure, which is 760 mm of mercury at the atmosphere. Right? Okay. Alright, so this is just the idea. So they said that in our atmosphere, tengok dekat point number 3, in our atmosphere, we have a nitrogen, oxygen, carbon dioxide as well as the water vapor. So water vapor tu we conclude it as the H2O lah, sebab dia adalah molekul air sahaja. Okay, so when you sum up all of this, you will get 760 mm of mercury. Okay. Alright, so now let's move on to this content. So we're going to take a look at the distributions or percentage of a certain gas that available, gas yang saya cakap tadi ni, in your atmospheric air. For example, let's focus on the oxygen lah. Okay, tak apa, kita go through one by one. Now let's take a look at the nitrogen. So nitrogen basically is basically the major gas that available in our atmosphere, but we do not notice that we have the nitrogen, right? So nitrogen is actually 78.62%, by which when you count in 760 mm mercury tadi, they are actually 597. 597 to 595, almost 600 mm of mercury tu dah ada nitrogen. But then, how about the oxygen? Oxygen is only 20% or 21% sahaja dekat atmosfer kita ni, ada 21% sahaja. When you calculate in the barometric pressure, you will get 160 or 159 mm of mercury of the oxygen that available in your atmosphere. I'm talking about atmosphere. Belum masuk dalam badan lagi. Dalam badan nanti akan berubah pula ni. Pressure of the oxygen nanti. Okay, nanti kita tengok kenapa berubah. Okay, so now let's move on to the carbon dioxide. So it is actually 0.3, really minute. But I do not know that in Johor, Sri Iskandar, dia dah start carbon free atmosphere kan. Mungkin lah dia punya oksigen tu mungkin lagi kurang lah kot. But right now, if let's say you are living in the very busy places, okay, kat KL ke mana-mana yang banyak enjin tu, maybe the concentrations of the carbon dioxide is slightly increase, higher. And now let's move on to the partial pressure of the H2O. Basically 0.5% lah. Okay. Alright. So now let's take a look at how does we calculate the partial pressure of a certain gas. Macam mana kita nak dapat partial pressure certain gas ni? Macam mana nak dapat amount ni? Macam mana boleh kira keluar macam tu pula? So the partial pressure of certain gas. So this, imagine that this is gas X. You need to get to know the barometric pressure. So what is barometric pressure? Tu yang 760 tadi. So 760 is barometric pressure. Okay. And then the fractional concentration tu apa pula? Fractional concentration ni. Fraction dia ni. Dalam percentage, fraction dia berapa. So how you going to know the partial pressure of the oxygen is that you take 20.9%, you multiply with 760, you will get 159 mm of mercury. That's what does that mean by the partial pressure of a certain gas. Ni saya dah tunjuk when you take the percentage of the oxygen tadi 0.2921, you multiply with 760, you will get 159. Okay, so now let's take a look at the relationship of the humidified gas. Tadi kita dah kira dah partial pressure of gas. Apa pula partial pressure of humidified gas ni? So humidified gas is basically telling you when the gas itself actually exists in a humidified area, its partial pressure gonna change. Why? Because in the humidified area, there are actually high content of the oxygen. So mean concentration tu dah akan berkurang dah. Macam tadi, kalau kita tengok sini, oxygen, water vapor kita ada 0.5 saja. Means that when you are living at the humidified region, this concentrations might increase. That's why it gonna affect that concentrations of the other gases. So is it important to get to know that, oh, when I live in the humidified region, oh, the partial pressure of the gases is reduced or increased? Is it important? Yes, it is really important when you're going to talk about your body system, because you have a nose. Sebab apa? Sebab saya ada hidung. Yes, when you look at the structures of your nose, you get to know, oh, hidung kita ada lubang, ada bulat, alright? Dia ada lorong-lorong yang boleh masuk kat dalam you punya trachea semua and what not before they get into your alveoli. Why? Because the air from the atmosphere, when you got into your nostril, into your respiratory tract and what not, before it reach to the alveoli, it's going to be humidified. That's why the partial pressure of the oxygen in the atmosphere going to be different when you compare with the partial pressure of the oxygen once it reach to your alveoli. Alright? So when I ask you, why is that important to get to know the relationship for humidified gas? That is the important. Okay? So in your body system, okay, you have a partial pressure. How can you calculate the humidified gas, the partial pressure of the humidified gas? So this is the formula. So this is a certain gas. You have a barometric pressure, and you need to you need to reduce or remove the partial pressure of water vapor. Okay, and then you multiply with the fraction, you will get 150 millimeter mercury of the oxygen. Okay. Alright. So, for example, let's take a look at this, the blue color and the red color region over here in this column. Okay, in this oxygen column, you may see that in the atmospheric pressure, partial pressure of the oxygen is 159. When it go to when it's being humidified, it's turned into 150, 149. And then in the alveolar air, it's further reduced. And then when in the expired air, it will be increased. Nanti kita tengok, right? Saya dah ambil oksigen dah masuk dalam saya punya nostril, oksigen dah being delivered into my alveoli, dah being transport dekat dalam sistem saya. Kemudian saya hembus nafas. Bila saya hembus nafas, my expired air consists higher oxygen comparing to my alveoli. Is it possible saya dah guna oksigen, lepas tu bila saya hembus, lagi banyak pula oksigen tu dekat masa saya hembus tu expired air tu. Why? Okay, nanti kita tengok Okay. Okay, this is what I mentioned with this value just now. Okay, inspired the air, it's being humidified. Once it's being in your alveoli, it's 104, but then when you expired it out, 120. Okay, so alright, so partial pressure gradient, I did mention when you have two partial pressure of a certain gas, then it will be established as a partial pressure gradient. Alright. Let's take a look at this example. Okay, we have a partial pressure of the oxygens in the atmosphere, by which it is 159. Partial pressure of the oxygens in the alveoli is 104. So kat mana tinggi? Dekat atmosphere lagi tinggi comparing to the alveoli. So dia akan diffuse from high to the low region. What about in the pulmonary capillary? So if we take a look at the partial pressure of the oxygens in the pulmonary capillary, from here, the blue color coded means that deoxygenated blood that coming from your heart being given back to the lungs. Okay. So the partial pressure of the oxygens in the oxygenated blood is actually 40 millimeter of mercury only. But in your lungs, it is 100. So yang mana tinggi? Daripada lung, oksigen tinggi, kat blood, oksigen rendah. Jadi oksigen will be diffused into your pulmonary capillary. Okay, and vice versa lah, carbon dioxide pula akan masuk ke dalam alveoli. So the concept of diffusions of the gases between these two gases is basically depending on the partial pressure gradient different. Okay, that konsep saya cakap panjang-panjang ni cuma nak cerita pasal partial pressure gradient difference sahaja. Alright. So this is just an example that we're showing just now. Tapi kenapa partial pressure at atmosphere 760, partial pressure of the alveoli is 760, betul ke? Betul lah, chamber ni tak tertutup kan, you punya hidung sampai ke lung you adalah open chamber. That's why the partial pressure is in the atmosphere when you total up at the barometric pressure, is just the same with the one in the alveoli when you sum up all of the cases lah. Alright, so if you take a look at this one, the one that I put an arrow, the red arrow right over here, it is actually showing you that the intrapleural pressure means that dekat pleura ni, so kita panggil dia intrapleural. Alright, so P pressure in intrapleural pressure is basically slightly reduced as comparing to the alveoli. So why do we have the concept that in the alveoli is high, in the intrapleural pressure is low? So it's basically going to show you that this is actually the closed area or closed space. The reasons why it's having a negative pressure comparing to this one, so that the lungs is easily going to be inflated. Okay, so maksudnya lung tu senang nak mengembang lah. Kalau kata you ada high pressure kat sini, lung ni susah nak mengembang. Sebab tu kalau orang ada pneumothorax, collapse lung, dia susah nak bernafas. Sebab apa? Sebab intrapleural pressure dia dah terbuka. Jadi pressure dia lagi tinggi. Bila lagi tinggi, lung ni susah nak expand. Okay. Okay. Alright, so now let's move on to the alveolar air. In the alveolar air, you have 104 just now, right? So basically in alveolar air, there has less O2 and more carbon dioxide. Okay, sebab apa? Sebab carbon dioxide tadi kan dah pindah masuk ke dalam alveoli. Okay, and oxygen pula, yes, less oxygen sebab dia dah mau masuk dah tadi ni, oxygen masuk dalam ni. Less oxygen ni comparing to what? Less oxygen is comparing to the atmosphere. Okay, so if you take a look at this, still oxygen is very high, but it's not as high as the atmosphere, and the carbon dioxide is at this region lah. And then all of these concentrations, the percentage of these oxygen and carbon dioxide going to be circulated throughout your body system, and then it's going to reach your tissue levels. So when in the blood capillary, before it reaches the tissue level, as it goes through your blood capillary, so blood leaving your lungs, entering the tissues capillary and whatnot before it reaches to the other cells, the partial pressure of the oxygen is now returning further, it become 100 mm of mercury. Okay, kita tengok oxygen je dulu. Just now in the alveoli is 104. When it goes into the arteries in your body system, when it leaving the heart, it is now 100 mm of mercury. Why? Okay, the reason is that kat lungs capillary tu ada red blood cell tu dia ada apa, blood vessel tu cell tak? It is cell. Jadi dia akan consume lah, dia pun nak buat kerja juga, nak buat metabolic process juga. Jadi as far as the oxygen pass through the system tu, oxygen sudah being taken up by the cells. Okay, that's why when it move further, the concentrations of the partial pressure of the oxygen is going to be reduced further. Okay, now let's take a look at the tissue level. So kat tissue level, in your tissue level, you may see that partial pressure of the oxygen is basically 40 mm of mercury. Dalam tissue kita ni, 40 mm of mercury. Dekat kapilari kita ni, 100 mm of mercury. Mana tinggi? Oxygen kat mana yang tinggi? So means that in our systemic artery, the partial pressure gradient is higher comparing to the tissue level. That's why the oxygen might diffuse from the capillary, it's moved to the tissue. Okay? So, oxygen akan pindah masuk kat sini. But, when you comparing to the partial pressure of the carbon dioxide in the tissue is increased. Sebab apa? Tissue dah guna dah tadi oxygen dan dia produce balik carbon dioxide, betul? So, carbon dioxide is higher comparing to the capillary. Then, the carbon dioxide will diffuse into the blood system. That's how the gaseous exchange occur depending on the partial pressure gradient. Okay? So now let's take a look at this one. Ini adalah systemic vein. Alright, this blue region is meaning that the systemic vein. So when your blood leaving the tissues and entering the lungs, so the blood leaving the tissues, entering the lungs later, so the partial pressure of the oxygen now becomes switch. Just now this one 40, right? This one is 100, right? So now it's changed. So they come back here with the partial pressure of the oxygen 40 mm of mercury. Just now in the tissue level, partial pressure is 40. Okay, sorry, in the blood systemic capillary, partial pressure is 40. In the tissue is 45. But then from high, one it already moved to the low region. Right now, the systemic vein going to get 5 mm of mercury of carbon dioxide. Now it become 40, 45. Tengok kat sini. Oh, tadi carbon dioxide 40 je. Lepas sel kita dah pudangkan balik carbon dioxide, it will become 45 mm of mercury. Alright? Okay. So the questions, alright, I've already mentioned you about this one, so we can skip this portion. So what we're going to say here is that the partial pressure is basically different at various regions. In the atmosphere, it's different. In the lungs, it's different. In the blood capillaries, it's different. In the systemic vein, also different. Systemic artery, yang sebelah sini systemic artery is different, and systemic vein is different, and tissue level as well, it is different. Alright, so now let's move on to the transport of gas to the peripheral. Alright, so how does the gas being transported? We already get to know the concept of partial pressure, and how does this partial pressure influence the diffusion process and whatnot. That's the end of that part of the gas diffusion or gas exchange only. So now let's move on to the how does this gas being transported in the system before it being delivered into the tissue. Maksudnya dalam blood circulatory system kita ni apa benda, apa transport yang bawa? Naik bas ke? Is it ride a bus? Is it a taxi? Is it an airplane? Is it a horse? Dia naik kenderaan apa? So that it be, ataupun dia jalan kaki je sampai kat tissue. Itu adalah layman term dia. So the concept is that how does this gas, sakit tekak sangat, so control. So how does this gas being transported to the peripheral? Alright. So first let's move on to the oxygen first. So how does this oxygen being carried out in your circulatory system? Oxygen's being carried out in two forms. So form number 1 is in dissolved form, and form number 2 is a combined form. So what does that mean by dissolved form? Dissolved form means that the oxygen is dissolved in the plasma lah. Kita ada dalam blood, kita ada blood plasma kan? So how does this oxygen being dissolved in the blood plasma? Okay, so a second form is that it's going to be combined with a protein in our blood system, which is known as the hemoglobin. Hemoglobin tu protein lah. Globin tu adalah protein. Alright, so now let's move on to the dissolved gas first. If you take a look at this one, at the bottom right corner right over here, you might see that oxygen is basically being dissolved in the plasma. Dalam ni red blood cell. Dalam red blood cell tu ada dalam blood capillary ni ada apa? Ada red blood cell dengan blood plasma. Kalau awak tengok blood tu, kita centrifuge, dia ada dua region kan. The bottom one is the red one, is actually the red blood cells, and the clear top bottom is actually the plasma. So inside the plasma, what are they? Platelet lah, apalah semua dalam plasma, right? So, back to the dissolved oxygen, only 1.5% of the oxygens are dissolved in the blood plasma. The rest of the oxygen, which is 98.5%, it's going to ride a transport by which it transport is hemoglobin. Okay, so oxygens, they only have two transport system, either it's jalan kaki or it ride a car, which is the hemoglobin. Okay, jalan kaki ni yang dissolve ni lah. Okay, contoh bahasa pasar dia. Alright, so the amount of the oxygen dissolved in the liquid in the blood is actually proportionate to its partial pressure as well, back to the Henry law, and depends on the solubility. So the higher the solubility of the gas, it can be easily distributed in the circulatory system. So how can we calculate the concentrations of the dissolved gas? So back to the fizik pula lah kita buat kunci kira fizik pula. So how can we calculate the concentrations of the dissolved gas? Kita tahu kan 1.5%, tapi concentration dia berapa? Alright, so what is the concentrations of 1.5%? Concentrations of the oxygen in 1.5% in the plasma. So how are you going to know? You take the solubility of that gas, alright, you multiply with 100 of blood. Then basically in our 100 milliliter of blood, we have 0.3 milliliter of oxygen. Okay. So kalau you ada 5 liter blood, dalam badan kita standard 5 liter lah. 5 liter blood, you kalilah tadi 0.3 dalam 100 tu, you are actually having 15 milliliter of oxygen that being delivered per minute. Okay. Dalam 100 blood, 100 ml blood tu ada 0.3 milliliter of oxygen sajalah. Okay, jadi if let's say you only depend on the jalan kaki je nak sampai pergi ke tissue you tu, which is a dissolved gas, dissolved oxygens to be delivered to your body tissue, is it adequate? 15 ml per minute, cukup ke? 0.3 ml of oxygen je, is it adequate? No, the oxygen is inadequate. That's why whatever it is, you still need hemoglobin as a transport system to carry these oxygens to be delivered to the tissue. Okay, the soluble oxygen, dissolved oxygen is actually not enough. Okay, so basically at rest, our oxygen consumption is 250 ml per minute. Tadi kalau awak kira dissolve je, the dissolved one is only 50 ml. But per minute, your oxygen concentration need is 250 ml. Is it enough? No, it is enough. That's why you really need hemoglobin. Okay, there you go on the hemoglobin. So the second part, how does the oxygen being delivered, is via hemoglobin. It's formal transportation. Kenderaan rasmi dia adalah hemoglobin. So let's take a look at the hemoglobin. So what is hemoglobin actually? Hemoglobin is actually coming from the term hem with globin. Hem campur globin. So inside heme, you have iron and porphyrin ring. Okay, iron and porphyrin ring. Ni ada kat sini lah, ada iron dia attached to the porphyrin ring. And you have a globin. Globin tu apa pula? Globin actually a 4 protein polypeptide. Okay, you have 2 alpha and 2 beta. 2 alpha yang orange ni, 2 alpha lah, ada 2. 2 beta yang biru ni, jadilah jadilah globin, 4 globin. When heme ni campur dengan globin polypeptide ni, jadilah hemoglobin. That's where the terms coming from. So, is it important to get to know what amino acids that contributing to the alpha change? What are the amino acids that contributing to the beta chain? Yes, it is. It has a significant contribution. So means that if let's say you change one amino acid to another amino acid, contohnya amino acid kita ada apa? Taurine, glutamine, valine, apa belah. You tukarlah saja. Saya rasa macam tak nak. Saya nak tukarlah dengan amino acid lain. Boleh tak? Tak boleh. Because they have a significant contribution. So if you change one amino acid, it will change the whole structures of the hemoglobin and it will affect that kenderaan rasmi. Contohlah, you beli kereta. You bought a car. You bought a car but that one is not sporty enough. Then you want to change your sport rim to 18 inches sport rim. You beli Asia je. You 13 je nak masuk 18 inci. You rasa-rasa dia boleh berjalan. So dia tak boleh berjalan. So that is the things that I'm going to mention, that they have a significant contribution. If let's say I have an Asia but still I want 18 inches sport rim, buanglah dia punya spare bracket tu, biar dia lorong lubang aja. Boleh pakai 18. But it is bolok. Okay? It's just a commercial break. Okay. Alright. So let's move on to the differences in the amino acid sequence. If let's say you change this amino acid sequence, it's going to bring out another type of the hemoglobin. For example, like if you say you change valine polypeptide, valine amino acid, so it's going to be hemoglobin A. What are the types of hemoglobin that we have? We have the hemoglobin A, we have the hemoglobin F, and we have the hemoglobin S. So A is basically adult lah, normal adult, like we are right now, normal adult. So we basically having a hemoglobin A. So fetal inside the womb, they basically having the hemoglobin F. So meaning fetal. But once they grow big, this hemoglobin F going to be changed into hemoglobin A. Macam mana hemoglobin dalam badan dia dah F, tapi bila dia besar tukar jadi A. Awak kena tengoklah hayat red blood cell tu. Bila red blood cell tu, bila dia besar, red blood cells half-life berapa, nanti bila dia produce a new red blood cells, dia akan change into a HbA. Nanti saya tanya soalan. Okay, so now let's take a look at the hemoglobin S. So hemoglobin S is stand for sickle. So sickles means sickle cell hemoglobin lah. So pernah dengar orang cakap ada satu disease which is a sickle cell anemia. So maksudnya hemoglobin itu jenis yang sickle. Alright. So When we talk about hemoglobin, so red blood cell is actually under the productions or under the control of the erythropoietin. So erythropoietin is actually hormone that is produced by kidney. Okay, the kidney itself, kidney kita tu bukan saja nak filter you punya air kencing, but they have a sensor by which this sensor going to detect the amount of your hemoglobin that presents. If let's say you have low amount of the hemoglobin, then this kidney will release erythropoietin. Okay, then they will sense and give release erythropoietin, and this erythropoietin gonna tell your bone marrow to produce the red blood cell further. Alright, your spleen now. Okay, so this production is stimulated when the amount of oxygen delivery in the kidney is really low. Okay, so what about the hemoglobin cycle just now? So I did mention that amino acid sequence in the hemoglobin, valine for example, in the beta chain is basically present in hemoglobin S instead of glutamic acid. Okay, so basically in the change of the amino acid change, blah 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 yang panjang kat dalam beta chain tu, in a normal persons there is a glutamic acid, but then in the sickle cells they're being replaced by the valine. Right. So what? So when they're being replaced by the valine, so what? So when the person is having the hemoglobin S, this deoxygenated hemoglobin S, meaning that once this hemoglobin S has give away the oxygen, their hemoglobin is actually very poor solubles and they can crystallize. Alright, they being crystallized in the red blood cell. Red blood cell tu red blood cell aja. Dalam red blood cell ada hemoglobin, right? So they being crystallized in the red blood cells, and then they can change its shape. So when they change its shape, they cannot bend, they're not flexy. So and other than that, they are really fragile. So that's why those that having a sickle cell anemia, the red blood cells unable to effectively carry oxygen to the body due to this certain reason. Okay, this reason. Okay, now let's move on to the oxygens. Oxygens, how they bind with the hemoglobin. So just oxygens, they will gonna bind with the hemoglobin at the ferrum ion. So kita ada ferrum kan? So dia akan bind with the hemoglobin, forming the ferrous ion. So heme containing ion to reduce from the ferrous ion, and the binding they will form the oxyhemoglobin, and this oxyhemoglobin are actually reversible. Alright, so dia boleh jadi oxyhemoglobin. So jadi bila dia pergi dekat tempat yang kurang oksigen dekat pressure gradient tadi, they will give away that oxygens and take back the carbon dioxide and bring carbon dioxide pula. Dia macam grab car lah. Okay, grab car. Alright, so heme has ability to bind oxygen reversibly and carry to the tissue, and it also facilitate the exchange of oxygens and carbon dioxide between lungs and tissue. Okay, so because they are actually a primary medium of gaseous exchange. Okay, so this is just the reactions that I mentioned to you just now. When we have one oxygen molecule bind with the hemoglobin, they form the oxyhemoglobin. But we have to bear in mind that in our red blood cell, we have 4 hemoglobin. So 4 hemoglobin will bind with 8 molecule of oxygen. So one red blood cells can bind with the 8 molecule of the oxygen. Okay, so basically, if you take a look at this structure, we just imagine that this is your hemoglobin in your red blood cell. Sepatutnya saya the red blood cell kat sini so that easy for you to see. So in your hemoglobin, this is actually in unbound shape. So it means there is no oxygen being attached to this one. Okay, so when they are being unbound to anyone, they are actually having a tense state. Maksudnya dia tension lah, dia tak boleh bind dengan oksigen. But then when one oxygen stream bind to it, it's going to be further relaxed. So masuk oksigen lagi, dia relax lagi. What does that mean by relax? So relax mean it's increase its affinity to bind more oxygens on it. So actually when it is not binding to any of the oxygens, it's going to be tight. It's not open a space. Macam awak lah tak kenal, tak nak bercakap. Bila dah kenal baru nak bercakap. So sama lah when it's bound to one oxygen, so it's easily bind to another oxygens and being filled with the oxygens. So oxygens, when it bind to the hemoglobin, we call it as the oxyhemoglobin. But then when it give away the hemoglobin, they give away the oxygen, when the hemoglobin give away the oxygen, they still in the form of ferrous form. Dia tak jadi ferric form, in the form of ferric form. Okay, and that hemoglobin we call it deoxyhemoglobin. Okay, boleh. So oxyhemoglobin is not actually oxidized hemoglobin. Dia bukan oxidized hemoglobin lah. Oxidized hemoglobin adalah ferric. Okay, dia bukan oxidized hemoglobin. Oxyhemoglobin is not oxidized hemoglobin. Remember, they are actually ferrous. Okay. Met hemoglobin apa pula? Met hemoglobin tu lain pula cerita dia. Met hemoglobin ni sebenarnya hemoglobin that in your muscles. Okay. If let's say a person having a very high percentations of hemoglobin in their body, contohnya Raju ada 97% hemoglobin. Okay. Ali ada 100% hemoglobin. So siapa yang lagi tinggi? Ali lah. So yang ada orang yang ada hemoglobin yang tinggi, we call it as the polycythemia. So kalau orang tu ada banyak hemoglobin, oxygen carrying capacity dia bertambah ke? Yes, the oxygen carrying capacity is increased. But bear in mind, a polycythemia is actually not good lah. You have to have a normal amount of the hemoglobin, not extra amount of the hemoglobin. Okay. Contoh macam orang yang nak pergi berlumba kan, dia nak increase oxygen carrying capacity kan, dia ambil satu drug untuk increase oxygen carrying capacity dia. EPO kan dia panggil kan, erythropoietin lah, dia ambil EPO kan untuk tambahkan red blood cell dia, untuk tambahkan hemoglobin dia, so that oxygen carrying capacity dia increase, jadi badan dia tak penat masa dia nak berlumba lah, berlari ke tournament ke apa ke. Itu yang kita panggil cheating tadi tu. So that is actually not good, because later it will induce polycythemia as well lah. So now we done with the oxygen carrying capacity, we done with the oxygen concentration, so we done with the oxygen, we done with the hemoglobin and whatnot. Okay, now we're going to move to the oxygen saturation. So what does this oxygen saturation means? That you have oxygen, you have hemoglobin, so how much is oxygen gonna bind with your hemoglobin? Tu kita panggil oxygen saturation. So the amount of the oxyhemoglobin is actually proportionate lah. Now kita dah campur. Tadi saya dah ajar partial pressure of oxygen saja kan. Kemudian I taught you on the hemoglobin dengan oxygen pula kan. But now when we talk about the oxygen saturations, so how much oxygen we're going to bind with the hemoglobin? It's actually proportionate to the partial pressure of the oxygen. When you have high partial pressure of the oxygen, hemoglobin is easily going to bind with the oxygen. When you have low partial pressure of the oxygen, hemoglobin binding affinity toward oxygen is going to be changed. Alright. So how do we know? So when they plot oxyhemoglobin, means that oxygen bind with the hemoglobin, plot to the partial pressure of the oxygen, they got hemoglobin dissociation curve. Ta-da! They got come out with this graph. So what does this graph mean? So this graph, actually look at the x-axis, it's going to tell you its partial pressure of the oxygen. So right now, when we show you 100% means 100% of the partial pressure of the oxygen, 100 millimeter of mercury, 100 millimeter of mercury of partial pressure of the oxygen in the lungs. And at tissue level, when you recap back tadi yang saya cakap dekat tissue partial pressure berapa, so partial pressure of the oxygen at tissue level is actually 40 millimeter of mercury. So now we're going to take a look at the binding affinity of the oxygens and hemoglobin at certain partial pressure of the oxygens in our body region. Okay, so now let's move on to the lung first. When you have partial pressure of the oxygens at 100 millimeter of mercury, 0.00000, you map here, the oxygens and hemoglobin, which is oxyhemoglobin, or the affinity of saturations of the oxygens toward the hemoglobin is actually 100%. Means that hemoglobin kita tu bind berapa banyak oksigen. So 100% our hemoglobin binding to the oxygens at 100 mm mercury of partial pressure of the oxygen. But then when you move to the tissue level, so how much hemoglobin binding with the oxygens at tissue level? You will see that there is oxygen's binding affinity or oxygen saturations with the hemoglobin at 40 millimeter of mercury is reduced. Okay, now it becomes 75%. So what does that mean, 175%? So means that oxygen bind with the hemoglobin 75% only. So dia ada 25% lagi kan. So 25% tu pergi mana? 25% lagi tu oksigen tu dah tak dibind dengan hemoglobin, but then it being released into the tissue. That does that mean? Okay, you get it? You get my point? So the importance of telling you this oxygen hemoglobin dissociation curve is actually going to show you how much oxygen is being delivered to the tissue. So at the lungs, oxygen binding with the hemoglobin is 100%. When it comes to the tissue kat sini, oxygen bind to the hemoglobin is 75%. So in between here, you get 25%. So it means that only 25% is being delivered. Ni dah tunjuk dah. Volume of oxygen that being unloaded to the tissue. Okay. So the one that I write or I put a red arrow right over here is basically going to show you that at 60 millimeter of mercury, for example, like those who travel at high mountain or at the high region lah, mountain or whatnot. So the partial pressure is actually 60 millimeter of mercury. So it's 60 millimeter of mercury here. How about the oxygen's binding affinity towards the hemoglobin? So it's actually 90%. So when you have 90% oxygen being saturated with the hemoglobin, you can still breathe. Your cell can still carry out metabolic process. The oxygen can still being delivered to the tissue. But then how much is being unloaded? Daripada sini 60 ni going to the tissue, berapa banyak yang being unloaded? You tolaklah 90, 75 tolak 90. Berapa? Sebanyak ni sahaja that being delivered to the tissue. That's why those who live at a high mountain, they have a difficulty in breathing. Basically, those who adapt to the high mountain, dia boleh dah adapt dah, maksudnya dia ada homeostasis process, dia boleh survive. But then if let's say you are actually down here at the sea level, but then suddenly you go to the high altitude place, so you might have difficulty in breathing. Okay, sama lah macam you panjat Mount Kinabalu pun, you akan termengah-mengah dekat atas sebab oxygen delivery you dah kurang. Okay, so oxygen carrying capacity of the hemoglobin is 1.334. So the amount of oxygen that been transported in the blood, oxygen carrying capacity is depending on the amount of being transported in the blood. Normal hemoglobin content is 15%. So 15% multiply with the oxygen hemoglobin binding capacity is to become 20.1%. So since percentage of saturation of oxygen is 95%, so 95% multiply, so you will get 19 milliliter per deciliter. Deciliter ni 100 milliliter lah of oxygen being distributed. Okay, so now let's take a look at the arterial blood. Okay, the percentage of the oxygen saturation is 97. You bawa 97, tapi dekat venous blood you bawa 75. Jadi you tolak lah, tengok berapa persen yang dibawa. Okay, so yang ni highlight apa? Highlight kalau kat 50% saturation, berapa partial pressure yang 50% saturation tu. The 50% oxygen saturation is actually occur at 27 mm of mercury. Okay, so okay, ni tak ada dah cerita tadi. Okay, now let's take a look at the oxygen delivery. Okay, so in the arterial content, just now we calculate right over here, kan kita dah calculate tadi kan, sini calculate sini, yang ni kita calculate ni. Okay, look at this table. You may see that at the arterial content it is 19.8 mm of mercury. At venous content it is 15.2 mm of mercury. So how much oxygen being delivered? Sini 19, sini 15. So tolak dapat berapa? Your oxygen delivery to the tissue is 4.9 milliliter. So in 5 liter blood, maksudnya dalam 5 liter yang dalam badan you yang ada tu, how much oxygen being delivered? It is 230 milliliter. Okay. Okay, so alright, so now let's move on to the changing affinity of hemoglobin. Just now we did mention about how does oxygen being bind to the hemoglobin, but we have to bear in mind that this hemoglobin are actually very dynamic. Sometimes it might have reduce its affinity to bind to the oxygen. Sometimes it might have high affinity to bind with the oxygen. Maksudnya macam ni. Means that ada kala dia senang nak bagi oksigen, ada kala dia susah nak bagi oksigen. Hemoglobin ni dia ada mood dia juga. So the changing affinity of hemoglobins to the oxygens is one of the homeostatic mechanism. So means that when your body, your tissue really need oxygen, so the hemoglobin easily gonna give the oxygen. If let's say your tissue does not need so much of oxygen, they're going to keep that oxygen. Okay, so the dynamic lah. For example, let's move on to the, for example, that we give an exercise condition. For example, when you do exercise, your heart rate increase, your metabolic needs also increase, your cells need a lot of oxygen to carry out to produce an energy and whatnot. Nak buat Krebs cycle nanti kan, nak pakai oxygen kan, nak oxidize itu, nak oxidize ini kan. So, the affinity of the hemoglobin towards the oxygen is going to be reduced. Why? Tissue kita nak pakai oksigen. Hemoglobin pun nak pegang oksigen juga ke? Nak kerekut juga ke? Cannot. They need to give away the oxygen. That's why the binding affinity at that time in exercise, for example, is reduced. The binding affinity of the hemoglobins towards the oxygens during exercise mode is reduced so that it's easily give oxygens to the tissue. Okay? Alright. So other than exercise, there are several factors. This is the basic factors that affect the binding affinity of the oxygens toward the hemoglobin. So we call it cadet phase right. So kita tengok kat sini balik graf ni cadet phase right. So what does that mean by cadet? It is carbon dioxide, acidity, maksudnya bila banyak hydrogen plus, right? H plus ion, hydrogen ion, or 2,3-DPG. 2,3-DPG atau DPG ni apa pula? Diphosphoglycerate. This is actually the metabolic side product from the red blood cell lah. Alright. So kalau red blood cell tu buat kerja banyak, so dia ada metabolic product dia lah. Apa maksud dia buat kerja banyak? Dia digunakan banyak, so dia buat kerja banyak lah. Alright. Kalau exercise, dia guna dia banyak kan. So banyak lah, increase saja. So in exercise or in increase in temperature. When, okay, just give you one example. When you do exercise, your body temperature going to increase, right? And your carbon dioxide also increase, right? When there is high concentrations of carbon dioxide, the H plus also will be increased, so means the acidity is increased, and red blood cells as well are doing a lot of work, so 2,3-DPG as well will be increased. So these conditions going to be shifting the graph to the right. Apa maksud graph to the right tu? Macam ni lah. Just now kita tengok the pink one over here is actually a normal graph. When increase in activity, this graph gonna shift, is skewed to the right, so means that the hemoglobin binding affinity is reduced. If it shift to the left, so means that the binding affinity of the hemoglobin gonna be increased. So that's what does this mean. Okay. Okay. So decrease the affinity of the oxygens when the blood pH drop or increase in carbon dioxide is basically called as the Bohr effect. Right? Bohr effect. So sama lah. Increase in temperature. Apa yang cadet phase right tadi means that it's going to shift to the right. So when it shift to the right, it means that the hemoglobin going to easily give oxygens. Okay. So now let's move on to this one I already mentioned. So now let's take a look at the hemoglobin F. So we do have the we do have the binding affinity of the hemoglobins toward the fetal blood. So fetal blood basically have high affinity, oxygen's affinity towards the hemoglobin is high. So what does that mean by that? So it means that fetal blood is barely or hardly to give oxygens. So what? Basically, that one is actually a survival mode lah. So it means that when the mother itself is lacking with the oxygens, the fetal still can survive. Okay. So this is showing you the fetal blood shifting a bit left comparing to the adult hemoglobin. So this is internal respiration and this is external respiration. So what is myoglobin? Myoglobin are actually found in the red muscle fiber. So they are also facilitated in the oxygen uptake and delivery. Okay. Right. Okay, for the carbon dioxide transport, I will shift to the next video. Okay.